dark matter. Yeah, this mysterious, undetectable stuff made of who knows what. You're not going to believe this. Well, I'm not sure I believe it. Anyway, yeah, this doesn't make sense to me, so it is thought to exist by a lot of scientists. There are dissenting voices who think there are better explanations for the phenomena that we see in galaxies regarding their rotation around the centre of the galaxy. In a lot of galaxies it doesn't seem to, the rotation speeds don't obey the mathematical rule that we have for their motion. So stars are held in their orbits by the mass of their galaxy within their orbit, by the gravitational force exerted by the mass of the galaxy on an individual star. Okay, now the gravitational force is given by an equation I'll just do a little diagram here. F equals G m1 m2 over r squared, where if we take this is a diagram of our solar system with the sun as m1, a planet m2 and r the distance between them. So the force holding that planet in its orbit is given by this formula. Okay. G is just a gravitational constant. So the further away the planet is from the sun, the less its velocity, the slower it's moving. So if we plot on a graph the rotation curves of, say, several planets or stars, we get a graph with velocity against distance. We get a graph like the blue line on this diagram here, where the velocity falls off quite rapidly with distance. Okay. Now when galaxies were looked at, I think the rotation curve I'm going to show was done on a spiral galaxy. It was found that the rotation speed of the stars around the centre did not fall away with distance, but it was like the red line, where stars at a great distance from the centre were travelling as fast as those close to the centre. Okay, as the red line on the graph, on the diagram. Okay. You see that the distance between these lines increases. The distance between these two lines increases with distance away from the centre, obviously. So enter dark matter. There must be more mass acting on these distant stars to allow them to travel faster. Okay? Yeah, okay. So if you can visualize it, there's this stuff which we can't see or detect in any way, which is distributed in a non-uniform way within galaxies. Obviously, the amount of, if it's dark matter that's causing this, then the amount of dark matter increases away from the centre to account for, to make the equation work. Okay? Now there are many different types of galaxy with different structures. So if we accept the existence of dark matter, then these galaxies must have different ratios of visible to dark matter. For example, apparently spheroidal galaxies are thought to have a low dark matter content, but many dwarf spheroidals have fast-moving stars, which indicates a high dark matter content. And on Wikipedia I also found that ultra diffuse galaxies, well, Dragonfly 44 may be made almost entirely of dark matter. An ultra diffuse galaxy. So it must have very fast moving stars. Which couldn't possibly be held in their orbits by the mass of the galaxy. Yeah, they've just found recently another dwarf spheroidal galaxy, an ultra diffuse galaxy called NGC 1052-DF2, which is said to be, they think, is completely free of dark matter, no dark matter. Now this seems unlikely. I mean, can you imagine a process that could result in such a variety of outcomes? With such a variety of distributions of dark matter. Presumably, whilst the galaxies are being formed. Okay, we'll go back to the maths. The way they do it is M1 is the total mass of the galaxy. and they say that all the mass of the galaxy can be considered as being at the centre of the galaxy. Just like our solar system with the massive sun, which is the majority of the mass in our solar system, and remote, very small planets. Well, galaxies don't look like the solar system, do they? Here's a spiral galaxy. You can see that the spiral arms have a lot of stars in them. There's a lot of mass which is not at the centre. So I thought I'd just test this to my own satisfaction. So there we have a massive centre, which I have given the value 30 M, which is our M1, and a very small in comparison star, shall we say, the value of 2M, which is our M2. At a distance of 8 units, so doing simple maths, the force on that distant star is 15/16 G. I've left the G off for simplicity. So then I've compared this with the maths for a situation with the same total mass where I've taken 2M units to represent, say, a spiral arm. 2M masses, and I've done the maths again, working out the gravitational attraction between that one and our distant star, plus that one, plus that one, plus the central mass. So if you see the figures I've got, the central mass is now 24M. So I did the maths for that situation, and you can see that the result is entirely different. It's much larger. So the force in this situation is 2 1/9. Okay. So might that not allow something like the red line? For a rotation curve. Can you believe this? I'm not sure I believe it. Can it be this simple? Am I right? I can't see where I'm wrong. But it seems much more likely to me that the different speeds of stars in different galaxies is due simply to the different distributions of the visible mass, which just requires a bit more complex application of the gravitational equation that we already have. That makes more sense to me than this this stuff which we just cannot detect. Well, if I'm right, what does that suggest? Well, maybe the desire to find the universe weird and wonderful has blinded scientists to a more prosaic explanation that accords with normal common sense. If I was a cynic, I might suggest that these scientists just enjoy being members of an exclusive club, the qualification for which is a more perceptive and receptive intellect. Almost a race apart, I wonder. And of course, a simple solution like mine would bring to an end the necessity for the search for dark matter, which is presently keeping thousands of scientists occupied. But forgetting that cynical, maybe over cynical view, what I do find really weird and mysterious is the very existence of these highly intelligent minds, these scientists who seem to have completely different criteria, to me anyway, for the acceptance of these counterintuitive concepts. So what do you think? Could it be that simple? Think about it.